This narrated set of notes for Week 10, Part 2 serves as an introduction to Module 9.3. Here are the major themes for Session 3 in Module 9: calculating the net present value, exploring the internal rate of return, and working with auditing tools in Excel. In Session 9.3, you will be determining a payback period, calculating net present values, calculating internal rates of return, and tracing formula errors back to its source. Here is the visual overview for Session 9.3. If you are not familiar with topics of net present value and internal rate of return from previous coursework, you should plan to spend some extra time carefully reviewing the topics presented in this session. The payment, future value, end period, and present value arguments all corresponded to Excel functions. The rate argument also has a corresponding rate function that calculates the interest rate based on the values of the other financial arguments. The rate function is used primarily to evaluate the return from investments when you know the present value, future value, payment, and end per values. Here is the rate function with its required arguments listed. The only new one for us is the guess. The guess argument, which is optional, is used when the rate function cannot calculate the interest rate value and needs an initial guess to arrive at a solution. The default value we see here is 1/10. Here is a sample from Session 9.3 where you will calculate the interest rate based on the loan amount of $200,000 with 5 yearly payments of $45,000. Note that we are looking at this worksheet from the investor's perspective. Therefore, the PV, present value, listed as investment is negative cash flow for the investor. They are paying out $200,000 to invest in Ryan's business. The 5 yearly payments are positive cash flow as they will receive these payments as income from Ryan's QR shopper business. Based on those numbers, the investment interest rate is calculated to be 4.06%. Not a very attractive rate for a startup business to offer. Ryan will recognize that he needs to make a stronger offer to his investors based on that rate. So he will add dividend payments over the course of the last 3 years when he can afford to make these payments. We see these listed for years 3 through 5 in row 13. So in addition to the $45,000 a year payments, Ryan will offer dividends to the investor. After sweetening the pot with the dividends, you will calculate the payback period for the investor. The payback period is the length of time required for an investment to recover its initial cost. Look at the return on investment calculations in rows 16 through 23. Column C shows a running total for the net cash flow. Considering the $45,000 a year payment plus the dividends, we see that the investor will recover their initial cost in year 4 with a net return of $3,000. In year 5, the payment of $70,000 will result in a net profit of $73,000. So if things go as Ryan plans, they will receive a nice profit. Calculating the net present value. The payback period is a quick method of assessing the long-term value of an investment, but it does not take into account the time value of money. The time value of money is based on the observation that money received today is worth more now than later. Just ask anybody who's had to wait for their paycheck. The time value of money can be expressed in terms of what represents a fair exchange between current dollars and future dollars. You can use the PV function to calculate the time value of money under different rates of return. You can use the future value function to estimate how much a dollar amount today is worth in terms of future dollars. When calculating the net present value, we will be using the NPV function when the future payments are not equal. The PV function assumes that all future payments are equal. If the future payments are not equal, we need to use the NPV for the net present value to determine what would be a fair exchange. The NPV has arguments for the rate and payments. The NPV function assumes the payments occur at the end of each payment period and that these payment periods are evenly spaced. Choosing a rate of return. Risk is the possibility that the entire transaction will fail, resulting in a loss of the initial investment. Investments with higher risks generally should have higher rates of return. This is a reward for taking on the risk. At some rate of return, the net present value of an investment will change from a positive value to a negative value. The internal rate of return is the point at which the net present value of an investment equals zero. This is a popular measure of the value of an investment and provides a basis of comparison between investments. Investments with higher internal rates of return are usually preferred to those with lower rates of return. We can calculate the internal rate of return using the IRR function. The IRR function, like NPV function, assumes that the payments and payoffs occur at evenly spaced intervals. Unlike the NPV function, you will include the initial cost of the investment in the values list. This slide shows the internal rate of return equals the return rate when the net present value is zero. That's the inflection point. When our present value is above the curve, it will be positive, and when it's below the curve, it will be negative. When we need to calculate the internal rate of return for uneven time intervals, the NPV and the IRR functions will not work. Instead, we need to use the XNPV and the XIRR functions. These two functions calculate the net present value and the internal rate of return for a series of cash flows made at specified dates. Our last topic has to do with auditing a workbook. We will look at 3 auditing tools. A challenge with large and complex workbooks is that the cell values and formulas are interconnected. Changing the value of one cell can alter the value returned by a formula located in a completely different part of the workbook, in another worksheet. The source of the error can be unclear at first glance. Excel includes several auditing tools to help us explore the interconnectedness of the cells and formulas in a workbook. On the balance sheet, we see that there are errors in our workbook. Let's take a look at some of Excel's auditing tools that can help us track down the problem. We have a problem in row 9 for the total current assets and problems in row 6 for the values in cash. The first auditing tool we will consider is tracing an error. An error could be located in the cell containing the error value, or it could be in a dependent cell or a precedent cell. A dependent cell is one whose value depends on the values of other cells in the workbook. A precedent cell is one whose value is referenced by other cells. Note that a cell can be both a dependent cell and a precedent cell. To find the Trace Error tool, look on the Formula ribbon in the Auditing group, and then click on the down arrow and select Trace Error. To locate the source of an error value, you select any cell containing the error value and trace its precedent cells. Here we selected cell F9, and it traced back to cell F6, its precedent cell. If any of the precedent cells display an error value, you need to trace that cell's precedence, and so on until you reach an error cell that has no precedence. That cell is the source of the error values in all of its dependent cells. The tracer arrows provide a visual clue to the relationship between two cells. They point from precedent cell to dependent cell. A blue tracer arrow, as we see here, indicates that no error has been received or passed. Notice that we see the worksheet with the broken arrow. This is from worksheet cash flow, cell F23. So cell F6 is dependent on that precedent cell. The red tracer arrow indicates that an error has been received from the precedent cell F6 and passed to the dependent cell F9. We can use the trace tool to drill down to the cell with the error in it. One drawback to using tracer arrows is that they can clutter a worksheet. Sometimes you want to trace only a single formula to its roots. Another way to explore the relationship between cells in a workbook is by evaluating formulas. You can invoke this feature by selecting the Evaluate Formula tool from the Formula Ribbon's Auditing tools. This opens the Evaluate Formula dialog box, which will allow us to drill down through the cell references in the formula until we reach the origin value. Now we can evaluate, or if we need to step into the cash flow worksheet cell F23, we select the Step In option. The final auditing workbook tool that you will explore in session 9.3 is using the watch window. A watch window is a window that displays values of cells located throughout the workbook. When you change a cell's value, a watch window allows you to view the impact of the change on widely scattered dependent cells. The window also displays the workbook, worksheet, defined name, cell value, and formula of each cell being watched. We can add the cells that we want to monitor to the watch window. In Module Session 3, you will add 3 cells from different worksheets to the watch window and then observe how a change in the tax rate affects these values. So looking at our watch window, we see that we are looking at cells from the income, the balance, and the cash flow worksheets. This is the end of the highlights for Module 9, Session 3 that focused on net present value, internal rate of return, and auditing workbooks. If you have any questions or wish to discuss any of these features, please post to the class forum.